Hey, what's up, folks? Today we're going to work on identifying the major species in weak acid or weak base equilibria. We're going to do the first of two examples in this topic, and I suggest that we take the following process. That first we go through and identify any spectator ions that are present. Okay, so identify the spectator ions. And in our first problem example, we have sodium as a spectator ion, and that's it. Okay, so the spectator ions are going to end up being in the other category. So we can go ahead and put Na plus in there in the other. Then we have to think about what's present in the solution, and we have to determine what the added acid or base does to the solution. If we have an added acid, then that's going to react with any base that's in the solution. And if we have an added base, that's going to react with an acid that's already in the solution. Okay. So then the third part is we need to keep track of the moles with a reaction chart. So for the first example here, we have a base we're adding to a solution that has an acid. So let's write out the equation. So we're going to have acetic acid, CH3, COOH plus OH minus, giving us CH3, COO minus plus H2O. And now we want to keep track of our moles. So we'll have the initial number of moles that are present. And for acetic acid, we have 1 liter of 1.1 molar. So that makes 1.1 moles. For the OH, we have 1.9 moles. And we don't have any of the acetate yet, and we don't care about water. For the change part of our sort of ice chart or reaction table, we're going to subtract off the limiting reagent. So in this case, the CH3COOH is our limiting reagent because it has fewer moles than the OH. So we'll do minus 1.1, minus 1.1, plus 1.1, and we still don't care about water. Then our equilibrium, or our final situation, we'll use F for final. Our final scenario is going to be the sum of these initial and change rows. So it's going to be none of the CH3COOH. It's going to be 0.8 of the OH minus, and it's going to be 1.1 of the CH3COO minus. Okay. So we will have OH left in the solution. That will be a base. We'll have CH3COO minus left in the solution. That will be a base. We will not have any acids left in this solution because the acids are used up. And that is that. So we would, under the acids, we would not list anything. And under the bases, we're going to have OH minus and CH3COO minus. Okay, and that is it for this particular topic. Thank you.